There's an outside chance that an asteroid named Bennu will crash into Earth by the year 2300, making it one of the most hazardous space objects known to humanity. Though an impact is very unlikely, NASA sent the OSIRIS-REx spacecraft to visit Bennu and grab some intel, and even some actual rock samples. Delivery of those invaluable samples back to Earth is expected in 2023. I'm really excited today to be talking to three members of NASA's OSIRIS-REx mission. We have Daniella DellaGiustina. She is the acting deputy principal investigator of the mission. Pierre Haenecour, he's the lead of the sample analysis data archiving group. And Andrew Ryan, the lead of the sample physical and thermal analysis part of the group. Thanks so much for coming to talk to us about this fascinating mission.
Thanks for your interest.
Thank you.
Yeah, absolutely. Well, it's just such an interesting mission. And, to start with, I guess I'll ask you, Danny, first. Aside from having possibly the coolest name of any mission in operation right now, what actually is OSIRIS-REx and what is NASA's goal here with this mission?
So OSIRIS-REx is NASA's first asteroid sample return mission. And the mission objectives are encoded within our mission acronym. So OSIRIS-REx stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer. And so OSIRIS-REx is going to help us understand the origin of life. That's where Origins comes from, and the essential compounds that may have been delivered to Earth from asteroids. We also want to understand what primitive asteroids are made of, how that relates to meteorites that we have on the ground, and if that can provide resources at some point in the future to mankind. And then we also want to better understand the threat that some near-Earth asteroids could pose to our own planet, which is where the security in OSIRIS-REx comes from.
So why then is asteroid Bennu, which OSIRIS-REx actually, I believe, just left a couple months ago, having successfully gotten that sample, which is great. Why is it such a good target for meeting all of those kind of diverse goals?
A lot of what goes into choosing a target for one of these missions comes down to what is actually achievable, which asteroids are actually accessible by the spacecraft in terms of fuel requirements and the amount of energy that it will take to get there and the amount of time that it will take to get there. So there are, over 500,000 known asteroids in our solar system. And we narrowed it down from there to the near Earth asteroids, because those are the ones that share orbital space that's similar to Earth's orbit around the sun. Those are a lot easier to get to. And then we continued to narrow it down from there based on the scientific value. And we knew that we wanted to visit a carbon-rich asteroid because we are carbon-based life forms. So there's a lot of interest in how these materials may have contributed some of the building blocks of life to Earth in Earth's early history.
The idea that it does have some of these organic materials and can tell us about the early solar system, how does that tell us how life may have emerged on Earth?
So Bennu is what we call a rubble pile asteroid. So it's basically, you can see it as like a sedimentary rock that basically created whatever was leftovers from the early solar system. So it's literally the leftovers of planet formation. But what makes it even more interesting for us is because it's a carbonaceous asteroid. So it's enriched in carbon and water. So he has bioessential elements and those organic molecules that we think might have been delivered to the Earth in the really early stages of the solar system. That's
such an interesting duality of asteroids to me, the fact that they give life, but they could take away. So you're saying that in the early Earth, in early Earth history, there could have been an enrichment of these kinds of really important materials and ingredients for life from asteroid impacts.
Yeah, so literally just by accreting materials. So water and organics from those asteroids by impact could have accreted on the Earth's surface and accumulated, leading to having all those bioessential and unique organic molecules that then evolved to life as we see it today.
Got it. And, on this side of taking life away, you mentioned that it's relatively near to Earth. Is it hazardous at all to Earth, Bennu? And how can it sort of tell us a little bit more about how we can defend our planet from these asteroid impacts in the future?
So I think it's always worth stating right off the bat that there are no known asteroid impact hazards for at least the next 100 years. So we can all relax for 100 years. But Bennu is considered a potentially hazardous object because it does have this near-Earth orbit. So there is about a 1 in 2,700 chance of an Earth impact late in the next century from Bennu. But OSIRIS-REx has really helped inform our planetary defense efforts, and it's done so by allowing us to measure something called the Yarkovsky force, which you can think of as kind of a drift that's caused by solar heating, and it changes the orbits of really small objects like asteroids in the solar system slowly over time. But it makes it difficult to predict just based on orbital mechanics what the future path of an object will look like in the solar system a couple hundred years from now. So by flying in formation with Bennu, the OSIRIS-REx spacecraft has allowed us to measure the Yarkovsky drift over the past 2 years. And then we've also just learned a lot about the structure of these small asteroids from OSIRIS-REx. Pierre mentioned that they're rubble piles. And so, that kind of structure, that loose the loose binding of, a bunch of rocky material is going to be probably easier to mitigate than a solid rock. So just by kind of learning more about the structure of these things, we can inform some of our planetary defense future mitigation techniques.
And do you mean like that would be easier to mitigate and then it would be easier to sort of nudge it off course? Or are we going full Armageddon, explode this thing? Kind of.
So there is a couple of different ideas on the table for how we could do planetary defense if there is an impending threat. One is called a gravity tractor, and it's just kind of parking a big spacecraft near one of these asteroids and slowly over time, just kind of, nudging it off course by having another mass in its proximity. Another idea is impacting one of these asteroids and maybe not exploding it, but nudging its orbit. And the double asteroid redirect test, which is a NASA mission that is currently under development right now, is going to do exactly this in a couple of years.
Gotcha. Okay. And I would love all of your reads on this one. OSIRIS-REx successfully actually touched down last year and got its sample. And there was amazing footage from that moment. And I just, it's a really incredible thing. And as you guys know well, an extremely difficult maneuver to do. So given that you have years and years of working on this project, what's it like to then be at that moment of truth where there's just this really short moment that you have to pick up your sample and it's got to go right? What was it like to be watching that maneuver? I
was just going to say giddy, I think is the first word that comes to mind. Just this sort of the nerves, knowing that, we've done everything that we can to prepare. The commands are sent to the spacecraft, and it's now or never. Just watching, and we're all kind of watching together at that point, and feeling confident, but of course a little nervous because there's always a bit of unpredictability when you're doing this, because we don't know 100% the true nature of the material on the surface, and so there's always that element of when you're doing something like this that's never been done before on such a strange solar system surface.
I remember for me it was very interesting because I was actually teaching at the time. I was teaching an introduction about asteroids and comets at the time where it was all happening. So we basically just watched the live stream and get the updates as it was coming in. So it was really exciting to see all this the student reaction to all the first information coming on.
Right, absolutely. There's nothing like actually seeing the touching of the surface itself there, yeah. And Danny, what was it like from your perspective?
So at the time of sampling, I was in the position of lead image processing scientist for the mission. So that footage that everybody saw, my team was responsible for stringing it together. And so even though the light time between Bennu and us was only a couple of minutes, after tag, we had to wait several hours for the high gain antenna on the spacecraft to be in a good position to transmit the images back to Earth. So we were just, looking at the schedule and trying to understand when the first images would come in, and very excited, but also aware of the fact that we had to get a product out, this video, to both the science team and the rest of the world, so they could see exactly what happened. So it was kind of a balance of trying to contain my excitement and make sure we got something done that looked good and was calibrated correctly and could be shared with the world.
That's a whole bunch of different conflicting things, right?
Yeah, absolutely.
Danny,
I didn't have to do. Sorry?
I was going to say, Danny, I think you did a good job. I remember, watching the team. We have like a team group chat channel that we can, share things and discuss. And I remember seeing some of those first images pop up, T plus 6 or 7 hours after tag, and the excitement on the team as everyone was sort of trying to describe, what are we looking at here? Whoa, when the gas fired, it looked like a bomb went off, or did we just crush that rock with the tag head? And other people saying, no, I think we just moved it. So there was immediately there was this excitement and debate and scientific analysis going on with these images the moment they were on the ground. It's really fun.
It was so much fun. Yeah, absolutely.
After the sample collection, there was this kind of interesting problem that emerged where the sample container hadn't fully shut. And I wonder if you guys could just comment a little bit about what happened there and how the kind of problem-solving coordination in the team helped to resolve that and get that shut.
So we were able to collect a lot of sample of Bennu with our sampling mechanism, which was great, but so much in fact that we kind of jammed the opening of what we call our tag sammer or our touch and go sampling mechanism. And so to overcome the fact that there was a lot of material and it was overflowing and spilling out of the sampling mechanism, we worked to stow the sample as quickly as possible. And that wasn't plan A. We had originally decided we would do a maneuver that spun the spacecraft around with the sampling arm outstretched, and comparing how the spacecraft rotated before and after we had gathered that sample. Looking at that small change in rotation would give us a good sense of how much mass we had collected. But I think as folks saw from some of those images of the overflowed sampling mechanism, we couldn't do that. And so the team really came together quickly to stow that sample as soon as possible and prevent any additional material from leaking out.
So does that mean that it's kind of a mystery box, what's coming back to us? Like, do we not know very much about what the sample, how big it is and what kind of rocks it might contain? Or
one of the positive about overfilling the collector is that if you're looking really detailed at the first images of the sample head, you can actually see large rocks stuck in the head. So that provided some constraint on assuming the density of those rocks, and in volume you can get an idea of like how much mass might be already in the collector. So I think the last estimate I heard is well over this 60 gram target that the mission was hoping to collect. So we should be well above that 60 gram.
Yeah, I think we're looking in the 200 to 300 or gram or even more, that kind of range, which to convert that's about a half a pound, which is definitely going to be enough for the analyses that we want to do. We're really happy with that.
So yeah, what happens now? it's OsirisRex is on its way back. How's this going to get dropped off back at Earth?
The OsirisRex spacecraft will return to Earth on September 24th of 2023, and it'll drop off the sample in this return capsule that is really similar to the sample return capsule that was used on the Stardust mission. The sample is going to get dropped off in the desert in Utah in a military test range, and I think there's going to be a big party when that sample is returned, because so many of us have just been working years and years to make sure this successfully happened. And then on the other side of it, so many people are excited to get that sample into their laboratories.
And I just got to know the details of dropping off something like this. Like, does it parachute down? Is it in some kind of like shock resistant capsule? How do you make sure that your sample doesn't just like explode when it gets down to the ground, or it doesn't have a failure like that, given how valuable these samples are? Our
sample return capsule, it has a heat shield, and one of the ways that we, and as it descends down to Earth at some point, a parachute will will be deployed so that we kind of have a soft landing.
So only 25% of the sample will be allocated for sample analysis. The 75% that are left will be stored for future analysis in future generation.
And I think Pierre's point about, we're preserving 75% of the sample is really important. The curation facility at Johnson Space Center, they're building a new curation lab for these samples. And it's going to be very similar to the type of curation they've done with the Apollo samples that came back from the moon, all the moon rocks brought by the astronauts. And people are still analyzing those moon rocks very actively and learning new things because new technologies are developed. We figure out new ways to analyze these samples that 40, 50, 60 years ago, we couldn't even dream of. And so we'll be doing the same thing with these samples, preserving them for future generations so that bright, young, new researchers who come up with new ideas and new technology have their chance to analyze what we've brought back.
A lot of the new discovery are based on not just on new sample availability, but also on new technology. And so ensuring that we preserve the sample for the next generation and being able to detect, for example, if you think about the moon, like Andy was talking about, for many decades, we thought there was no water on the moon. And only in the recent years, we were able to actually measure that there is actual water trapped inside of minerals on the surface of the moon.
It's about getting new technology, but also about getting new questions that we realize we want to answer, developing new hypotheses. And in order to answer this hypothesis or question, there's a very specific measurement that you need to do. We don't do that measurement until we know the right questions to ask. And so, yeah, it's technological development, but also just the development of new ideas and new ways to think about the analysis of these samples and how they're related to the history of our solar system.
Say the capsule comes back, we open it, it goes to these labs, and there's very convincing evidence of some kind of microbial life, some kind of life form. What's the step after that?
So from my perspective, if there was evidence of something microbial, it would mean that we had contaminated the sample. Because Bennu is sitting out in space without an atmosphere and has been exposed to the really harsh radiation environment outside of Earth in our solar system for millions, billions of years. And so there is really no chance that life could survive that sort of harsh radiation environment. So if we did find evidence of something microbial, I would suspect there had been a contamination snafu somewhere along the way, and that was supplied by our planet.
Well, last, I wanted to just get a sense of how you all ended up in your current positions. Like if there's people watching right now that are thinking, I might want to be able to go and study asteroids or do sample return missions to space. What are some of, just if you could describe how you first got interested in these subjects and what took you to this path where you're now working on this fascinating mission?
So when I was younger, kind of investigating majors for college, I was actually really drawn to the humanities, philosophy and psychology. And I really thought that some of these big questions that we have about, where did we come from and what is our future, had their answers in kind of that side of the academic disciplines. And I took an astronomy course just to fulfill like a general education requirement my first year of college. And it completely turned my worldview around in terms of recognizing that science can hold a lot of the questions to some of these big answers, or at least hold some of the clues. And so I got involved I switched my major to physics, and I got involved in research on meteorites. And, looking at a meteorite that has been broken open for the first time and seeing a mineral grain in there that nobody has ever seen before is just such an incredible feeling. You really feel like you're on the edge of human knowledge. And the same thing, it happens all the time as a scientist. So being the image processing lead for the mission during its operations at Bennu phase, I was seeing pictures of boulders on Bennu for the first time right after they came off the spacecraft. And nobody had ever seen that before. It was probably the first, human who had ever seen that rock. And so that sense of just being at the edge of the limits of what we know about the world around us is such an incredible feeling. And it hasn't gone away. And it's why I really enjoy doing science.
I was always fascinated by rocks and minerals. I used to have a small collection of minerals as a kid, and I would pick rocks everywhere I could. I was always fascinated by it. It took until I took my first class about planetary science, which was about meteorites, where I realized you can actually hold a rock in your hand that's over 4.5 billion years old. And it's so fascinating to me that you could actually have that piece of rock that survives so many billions of years and so many processes, planet formation, landing on the surface of the Earth, and then was randomly collected by someone. And now I can hold it in my hand.
I kind of had a bit of a meandering path to get to where I am now. I didn't really get deeply engaged in the sciences in high school, like some people may have that are in positions like this now. In fact, when I went to college, I started out as a music major. So I was also very much in the humanities and arts. But at the end of my first year, I was feeling a little dissatisfied with that experience. And I know this may sound a little bit cliche, but I was actually at the Air and Space Smithsonian Museum in DC this summer after that first year, and kind of had this spark of inspiration, just seeing all of the interesting space exhibits and human exploration artifacts there. So I went back that next semester and decided I'm going to give sciences a try. And I eventually settled on environmental science because I really liked how it merged all these different disciplines together to understand our planet. And during that time, I discovered that there are all these NASA internships out there. And I thought, oh, this could be my chance. This sounds really cool. I didn't think I had a chance at all to actually get selected for any of these internships, but I applied to a whole bunch of them and I did get selected to one. And that was sort of my initial exposure. I did an internship at Johnson Space Center in Houston. I did another internship the year after. I decided to pursue a PhD in planetary sciences, and my PhD advisor was involved in OsirisRex, and so that was how I eventually got involved in this mission. But I always like to tell students, especially students that are at the university level, that maybe think, oh, it's too late for me to kind of get onto this track. It's definitely not too late. There are tons of interesting NASA and science internships out there. And even if you don't think you have a shot, you should apply, because, well, if you don't apply, then you certainly won't end up going to one of these. So you might as well just try it, and you don't know where you'll end up.